Welcome to our comprehensive guide on overclocking. In this video series, we will explore how to increase component speeds beyond their factory specifications. We'll cover everything from basic concepts to advanced techniques, risks, and safety precautions. Whether you're looking to boost gaming performance or improve productivity, understanding overclocking is essential for any PC enthusiast. Overclocking is the process of intentionally increasing the clock speed of your processor beyond its original factory specifications. Your CPU operates at a base frequency, measured in gigahertz or gigahertz. By raising this frequency, your processor performs more calculations per second, resulting in improved overall performance. However, this technique can be applied not just to CPUs, but also to graphics processing units, or GPUs, and even RAM. The fundamental trade-off is that higher speeds generate more heat and consume more power, requiring careful management. There are several approaches to overclocking your CPU. All-core overclocking is the simplest method, where you increase the same frequency across all processor cores simultaneously. This is ideal for beginners. Per-core overclocking is more advanced, allowing you to assign different frequencies to individual cores to optimize performance based on each core's capabilities. Software overclocking uses applications like Intel Extreme Tuning Utility, or Intel XDU, making it easier for newcomers but offering less control. Finally, BIOS overclocking, or firmware-level overclocking, provides maximum control but requires more technical knowledge and involves restarting your system. Several software applications are essential for overclocking. Intel XDU is the official Intel overclocking utility designed specifically for Intel CPUs on Windows. AMD Ryzen Master is AMD's equivalent, tailored for Ryzen processors with built-in profile support. MSI Afterburner is the industry standard for GPU overclocking and works on both NVIDIA and AMD graphics cards. GPU-Z and CPU-Z are invaluable monitoring tools that display real-time hardware information including temperature, voltage, and current clock speeds. These tools help you verify your overclocking results and ensure stability. Overclocking carries significant risks. Excessive heat generation is the primary concern. Higher speeds produce more thermal energy, and inadequate cooling can cause thermal throttling or permanent hardware damage. Your components will experience accelerated degradation due to increased voltage and heat, reducing their lifespan by 10 to 30%. System instability is common, manifesting as crashes, freezes, data corruption, and blue screen errors. Additionally, overclocking typically voids your manufacturer's warranty, so any hardware failure becomes your responsibility. Finally, overclocked systems consume 20 to 30% more electrical power, potentially overwhelming undersized power supplies. To overclock safely, begin by upgrading your cooling system with a high-quality air cooler or liquid cooler before attempting any modifications. Make incremental changes to your settings, testing stability after each adjustment. This approach prevents catastrophic failures and helps identify problematic settings quickly. Continuously monitor temperatures using software like HW Monitor or HYNFO, keeping your CPU below 85 degrees Celsius during stress testing. Perform thorough stress testing with software like Prime 95 or AIDA 64 for several hours to verify stability. Ensure your power supply has adequate wattage and voltage stability. Finally, back up your critical data before overclocking to protect against data loss from system instability. When overclocking, expect realistic results. Safe clock speed increases typically range from 5 to 20% depending on your specific hardware. Keep CPU temperatures below 85 degrees Celsius for sustained operations. Voltage increases should remain around 0.1 volt on average. You can anticipate gaming performance gains of 5 to 15% in frames per second, though actual results vary by application. Be aware that hardware lifespan reduction can range from 10 to 30% due to accelerated degradation. Power consumption will increase by 20 to 30%, so verify your power supply capacity before beginning. Several specialized tools are essential for successful overclocking. Prime 95 and AIDA 64 are industry-standard stress testing applications that simulate extreme workloads for hours, verifying system stability under maximum load. HW Monitor and HYNFO 64 provide real-time hardware monitoring, tracking CPU temperature, voltage readings, and current frequency during testing. CPU-Z and GPU-Z are detection and monitoring utilities that display core voltages, clock speeds, and detailed hardware specifications. Cinebench and Geekbench are performance benchmarking applications that allow you to compare results before and after overclocking to validate your performance gains. The BIOS or UEFI interface on your motherboard provides native overclocking control with maximum flexibility, though it requires a system restart to apply changes. If your system won't boot after overclocking, reset your CMOS settings or reduce the clock multiplier and return to your last stable configuration before retrying. When crashes occur during stress testing, increase voltage incrementally by 0.05 volts or reduce frequency, as insufficient power delivery causes instability. If temperatures rise excessively, improve your cooling system, reduce frequency, or lower voltage immediately, never exceeding 85 degrees Celsius. Blue screen errors indicate voltage instability. Increase CPU voltage slightly or decrease clock speed right away. If performance degrades over time, your CPU may be experiencing silicon degradation from unsafe voltage or thermal stress, so reduce your overclock settings immediately to prevent permanent damage.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.